download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about metallic bonding. Now metals want to lose their electrons to form full outer shells. Okay, so they want to lose their electrons to have full outer shells. Remember, really, it is atoms want to gain a full outer shell. The electrons in the outer shell of electron become delocalized. So if we draw here a sort of layer of metal atoms, what will happen is their electrons, and I'm representing that here as the tiny circles with a minus sign in it, become delocalized. Now it means they are free to move, leaving the positive ion behind. So they are delocalized electrons and they are free to move. Okay. The positive ions, which are left behind, are then attracted to these delocalized electrons, okay, by an electrostatic force of attraction. Okay, so these positive metal ions are attracted to the delocalized electrons by a strong electrostatic force. Yeah, remember that delocalized electrons mean the electrons are free to move. That's important when we start talking about the properties of metals. Now these metals therefore can go on to form giant structures that all are attracted to each other by the delocalized electrons. Okay, we call this metallic bonding. And this includes metallic elements, i.e. metal elements bonding to other metal elements, and also alloys, which we're going to get to in a second. It's the delocalized electrons in the metallic bonds which produce the properties of metals, and I'm going to explain that to you now. So, what are the properties of metals? Okay, the first one is that they have a high melting. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers and so much more. The link is in the description. And boiling point. Now, if you've watched the videos previously on the ionic compounds and the simple molecular structures, you will be used to the idea that if something has a high melting and boiling point, then therefore there must be strong bonds that require a lot of energy to break. And that's exactly what metals have. These electrostatic forces between the delocalized electrons and the positive metal ions are strong. Okay, so therefore metals have high melting and boiling point because of the strong electrostatic forces, and really importantly because these electrostatic forces require a lot of energy to break, therefore giving metals a high melting and a high boiling point. See, metals are also malleable. Now what we mean by malleable is that they are easy to bend and shape. Okay, so something that's malleable is easy to bend and shape. Now if I draw out the layers here of a metal, okay, these layers of atoms between the metal can slide over each other easily, as you can kind of see in this diagram here. They can slide over each other, and this is what makes them malleable, okay, because the layers of ions can slide over each other. So if you ever get asked the question, why is this metal malleable, it's because the layers of ions or atoms, metals or ions, can slide over each other. So why do they have high melting and boiling points? Because they have strong electrostatic forces that require a lot of energy to break. Why are they malleable? Because their layers of ions can slide over each other. They are also good conductors of electricity. Okay, now you'll remember from our previous videos that you need two things to be able to conduct electricity. You need a charge, so it needs to contain a charge, and these charges need to be able to move. While this fits our metal very well because they have a charge, the delocalized electrons are charged, and perfectly these delocalized electrons are also free to move. Therefore they can carry the charge between and through the metal, making metals good conductors of electricity. Okay, so why are they good conductors of electricity? Because they have delocalized electrons which can carry the charge. So therefore they can conduct electricity. So properties so far: high melting and boiling point, they're malleable, and they're good conductors of electricity. The final property that we're going to look at is that they also are good conductors of heat. Okay, they're good conductors of heat because, and again, because the delocalized electrons are free to move, they can transfer the energy around the metal and through the metal. So the delocalized electrons, because they're free to move, can transfer the energy, i.e. the thermal energy, through the material. And this makes them good conductors of heat. Okay, so very quickly, just to summarize, properties of metal: they have high melting and boiling points because of the strong electrostatic forces that require a lot of energy to break. They're malleable, which means they can easily bend and shape because the layers of ions can slide over each other. They're good conductors of electricity because the delocalized electrons, which have a charge, can freely move to carry this charge. And they're good conductors of heat because the delocalized electrons, because they're free to move, can transfer the energy through the material. Now we're just going to look at alloys. Okay, so pure metals often aren't quite right for certain jobs. Now what we mean by a pure metal is a metal that contains only one type of atom. So for example, if we were to look at gold and look at pure gold, then it would only contain gold atoms. Okay. Now these pure metals are often a bit too soft. So what then happens to them is they are mixed with another metal. Okay, they are mixed with other metals to make them harder. Most metals we actually use in everyday life are alloys, which is a mixture of two or more metals, or a metal and another element. So it doesn't just have to be with another metal, or a metal and another element. Now alloys are actually harder and so are more useful than pure metals. Okay, so if we draw our pure metals, they look like this, and they can easily slide over each other as they're malleable, as we just looked at in the properties. However, when you mix them with another element, what happens is they no longer form those straight layers, and therefore they become much harder to slide over each other. And because of this, it makes the metal much harder. So different elements have different sized atoms, as you can see here. So when another element is mixed with a pure metal, the new atoms will distort the layers. Okay, as you can see here, they've changed the lovely layer shape that makes it so malleable and so easy to bend, and it's distorted those layers, making it more difficult for them to slide over each other, as I just said, and therefore making them harder than pure metals. Okay, so why are alloys stronger and harder than metals? Well, it's because a different element, which is a different shape, distorts the layers of the metals, which means they make them harder to slide over each other. They don't slide over each other, which makes them harder than pure metals. So what we'd like you to now have a go at is answering these questions here. So pause the video now. Okay, so let's go through these questions. Explain why metals have high melting and boiling points. Well, that is because of the strong electrostatic forces between the positive metal ions and the delocalized electrons. These strong electrostatic forces require a lot of energy to break. Therefore, metals have a high melting and boiling point. Question 2. Copper is used to make wires for household circuits. Give 2 reasons why. One reason is because they can conduct electricity. They're good conductors of electricity. If we need wires, they need to be able to conduct electricity. So copper is a metal, and that is one reason why. Okay. Also, metals are malleable, which means we can bend them into shape. So copper can be bent into shape, into a wire shape more specifically, which means they're good for wires. Number 3, state the conditions under which an ionic substance will conduct electricity. It's a bit of a throwback to our ionic compounds video, so if you haven't watched that, please do. They can only conduct electricity when they're either molten, i.e. they're melted, or they're dissolved in water. Question 4, define the term malleable. Well, this means they can be bent and hammered into shape. Okay, so bent in and easy to bend in shape. So easy to bend in shape. Question 5. Describe how the structure of an alloy is different from the structure of a pure metal. When an alloy contains a different metal or a different element, these distort the layers between the metal atoms. And finally, suggest one reason why coins are not made from pure copper. Okay, do not give a cost reason. Well, pure copper would be much softer. We use an alloy of copper because an added element make them harder. Okay, because adding the element makes it more difficult for them to slide, the layers to slide over each other. So it makes the alloys harder than pure metals. So we use an alloy of copper because they would be harder than just pure copper. So I hope you understood that video on metallic bonding. You can now move on to the quiz and onto the exam questions as well. Okay, if anything you didn't understand on that video, then please do get in contact with one of our tutors and they will be happy to help.